Day 3, binary diagnostic. The submarine has been making some odd creaking noises, so you ask it to produce a diagnostic report just in case. The diagnostic report, your puzzle input, consists of a list of binary numbers which, when decoded properly, can tell you many useful things about the conditions of the submarine. The first parameter to check is the power consumption. You need to use the binary numbers in the diagnostic report to generate two new binary numbers called the gamma rate and the epsilon rate. The power consumption can then be found by multiplying the gamma rate by the epsilon rate. Okay. Each bit in the gamma rate can be determined by finding the most common bit in the corresponding position of all numbers in the diagnostic report. For example, given the following diagnostic report. Let me copy this. So we have 1, 2, 3, 4, 5 bits. The first bit, considering only the first bit of each number, there are 5 0 bits. So 1, 2, 3, 4, 5. And just to make sure that they're talking about the left side, 1, 2, 3, 4, 5. Yeah. So the first bit is on the left here. There are 5 0 bits and 7 1 bits. Since the most common bit is 1, the first bit of the gamma rate is 1. So we will need to store these, and I will need to be able to get the bit at a given position. And then I will also need to find the most common bit given a set of bits. Okay, the most common of the the most common second bit of the numbers is 0, so the second bit is 0. Okay, so we're producing a new 5-bit number based on the most common ones of these. So the gamma rate is a binary number 10110 or 22 in decimal. So in this case now, if I remember correctly, this is 0 and 1, so this is 2. And this would be out of 4. Is that right? No, 0, 2, 4. So that would be 6. This is 8 plus 16. 6 plus 16 is 22, yeah. So it is worth noting that we're processing these left to right when we're figuring out the bits, but the end result is still a binary number where the least significant bit is on the right-hand side. The epsilon rate is calculated in a similar way. Rather than use the most common bit, the least common bit from each position is used. So the epsilon rate is 0, 1, 0, 0, 1, or 9 in decimal. Multiplying them gives us 198. Okay. Cool. Any questions on this challenge? I will start off by... let's grab our day 3.test. And real quick, I'm going to peek ahead because, yeah, you notice that there's more than 5 in the puzzle input here, but they are all the same width. So we need it to work with any arbitrary width, but we can't hard code it to 5. Okay. So let's add a new folder, day 3. Day 3.swift. We can actually say read file day 3.test.lines. And let's just print them out so we can get something on the screen. And then in main, let's use day 3. Okay, so now we have our puzzle input. Okay, so in here we are going to have a struct diagnostics. And I think I want to represent each one of these things as a reading. And so when you initialize this, there's a couple of things we could do. We could have a string value, or we could have an integer value. Can you please show what read file does and how to get lines? Yeah, so I wrote that yesterday in util. Read file, this is a little bit of a hack, but it works for us when we're working on this in code. We're using the pound file to get the reference to this file that we're currently in. we delete the last path component. So now we get rid of the actual file name, and now we're in the advent of code. We append on resources, and then we use data contents of file URL to get the data. And then lines is an extension on string, which splits on new line characters and trims all leading and trailing white space from any lines that we have. Okay, so we have the option of grabbing an integer value or a string value, and each has their pros and cons. If we store it as, say we have something like that, I want to be able to get the actual bit at this position, and leaving it as a string actually makes that kind of, it means we have to like grab it as a string, convert it to an int, and then do math. Whereas if we store it as an internal, binary integer, then we could take advantage of bitwise operations to do what we're trying to do. So I think that's what I want to do, but it's worth noting that this number is going to be reverse of what we might expect. Let me see if I have a better way of describing that. So we can write our little test here. So let's say we have the input, this input right here. And then we want to get a number out of that. We can take that and use radix2 to get this string value represented as a number. And I think we have to force unwrap that. Oops. Right. Yeah, okay. And then we can print out the number. So what do we expect this number to be? At this point, it is 6. And is that what we expected? We are grabbing the bit from the right hand side, which is 1 or 0, plus this one, which is going to be 2 or 0. So that's 2 plus 4 is 6. So if we want to get the bit in the position on the left-hand side, so the 0th bit from the left, we can use the, we can AND this number. So we take num and we use the bitwise AND operation. And at this point, if I want to get the binary number 1, I expect this one to be 0. Because let's do this. Oh, I probably need to figure out a way to have it reuse the same scratch pad. Let's say they have a bit there, and I build and run. At this point, notice that the number is 22, which makes sense. The bit at the 0th position starts from the right-hand side. So this may be obvious to some, but it's worth noting that we need to think about this in 2 different ways, I think. So how do I get the position? How do I get this bit here? Well, I need to know how many bits to shift it over. So if I'm starting here and I need to go 1, 2, 3, 4 over. So it's the width of the number minus 1. So we'll say width. We'll have some sort of concept of width, which will be the number of characters. And then here we can bit shift this over by width minus 1. And at this point, we expect this bit to be 1. Oh, well, it's 16. So let's see. This one, when we're shifting over, it is giving us 16. Which makes sense because it's giving us a 1 in this position, but the resulting number needs to be shifted back over by the same amount, which is a little bit annoying. Width minus 1. There may be a better way to do this. Let's see. Shift this number over. Okay, so now we have a 1. So I'm hoping that makes sense of why, or how we're dealing with that. So in this case, I think that when we are given a string value, we will convert it to an int value. We'll just call it private let value. And this one will be an unsigned integer. And so here we will say uint string value radix2, and then set value equal to that. And I don't know if I'll need this yet, so let's just go from there. So at this point, we want to be able to say to get a bit at a position. And I want that to return an integer. So essentially, we're going to, let's see, we also need to know the width, I think. Private let width. There's probably a way to do this other than counting the string value.count. Yeah, that's fine. We'll return 0 for a second. There is probably a way to know how many bits a number is. Actually, no, there isn't, because we could just have infinite zeros leading off to the left. So yeah, so we'll store the width of our reading. We'll store the actual value as a value so that we can easily do bitwise operations on them. So now I can bring this over here, and we will take our value, and we are going to we're going to have some sort of shift amount, which is width minus 1 plus position, I think. Or minus position. Okay. So just to, let's say if our number is 5 wide and we want to get position 0, this will take 4 minus 0 equals 4, which was correct. And if we want to get position, or 5 wide and we want to get position 4, then this will be 4 minus 4, which is 0. Okay, so we should assert here and crash hard if the position is less than 0 or position is greater than or equal to our width. Okay. So returns the integer, the int value of the bit 0 or 1 of the bit at the given position starting from the left. Position is 0 indexed. Okay. So now we have our value. We've got our shift amount. So we're going to shift left by shift amount. And then we're going to take the entire thing and shift it back to the right by shift amount. And then this one will give us a integer. Okay, so let's, so we're going to print x. We're going to print the number that it is. And then for 0 in 0 dot dot less than width, I will print position I is, and we will print out let's get our reading. Reading string value is X. I don't actually need the X or the num. Yeah, I don't need num anymore. And I think I want width to be public, because there's no reason for me to do that either. So now I can just say reading string value. I'll say for each one reading.width, position I is reading.bit at I. And I have an extra backslash there. Okay, so let's just double check that we got, okay, our assertion failed. We are going 1, 2, 3, 4. We want to assert that the position is, not greater than or equal to 0, and less than width. Yeah. Okay, so in our string, we have 1, 0, 1, 1, 0, 1, 0, 1, 1, 0. Okay, so that's correct. So now we have our reading. We have our lines, so we can say let readings equals lines.map to reading.init. And at this point, I want to pass those off to diagnostics, like this. It doesn't know what that means. So let's go down here and say init readings is an array of reading. Reading. Okay. So now I have self.readings equals readings. Okay, so now in diagnostics, I want to be able to say, give me the common bit at position. And again, this is going to be a similar thing where position is 0 indexed from the left, assumes that all readings are the same length. So that way we don't have to we don't have to do that assertion here. I suppose that it would be valid for all readings to be the same length, but for the position to be at least less than the maximum reading width, which I suppose we could just make an assertion here rather than a comment. So we would assert that position is greater than or equal to 0, or position is less than, and we want readings.map to the width.max. Int to int. Max is a method. Okay, so we need to assert first that readings is not empty. And if we've done that, then we can force unwrap this one. Okay, this is going to return an unsigned integer, which we will have to do that. Okay, so at this point, we need to get all of the bits at the same position. So we're going to say bits, and then we will say that's readings.map $0.bit at position. And then once we have all of those, we can get to the sum of those bits by reducing, starting with 0 and using the plus function. So that will sum them all up. So in our case, if we had 1, 0, 1, 1, 1, it's just going to say 1, 2, 3, 4, and then we can divide by the total. And if the number is greater than 0.5, then that's a 1. If it's less than, it's a 0. So we can use integer division. So this would be return uint of sum divided by actually, integer division isn't going to work here. We need floating point division rounded, then cast to an integer. So this would be float sum divided by float readings.count. And again, we're protected against dividing by 0 by this assertion up here. So once we have that, then we can say dot rounded, and then this whole thing needs to be cast to a uint. Okay. So we've got the common bit here. We also have the notion of a least common bit, and it's essentially the same thing. And because it's a bit, we can just say that this is 1 minus the common bit. Because if we got a common bit of 1, 1 minus 1 is 0. And if we got a common bit of 0, then this becomes 1. So it's essentially like a not operation. These functions can be private because they're just going to be computing what we're dealing with. So we want the gamma rate to be an int, unsigned integer. And this is going to grab all of the common bits. This one's going to be interesting too. So we want to, so for I in 0 ... less than, and we'll just grab readings.first .width. We will say guard readings not readings is empty, else return 0. So we know we have at least 1. We can just do this. So we're just going to start with the first reading width, assuming that that's the one that we're going to be dealing with. There's no requirements for how to deal with entries of varying width anyway, so we could sort of encode our assumptions so that we don't crash in unexpected ways, but I don't think we need to deal with that requirement. Okay, so we can say give me the common bit at position. And then I need to take that bit and move it into a new number. So we can start at 0. And then we can say num plus equals bit shifted by I. Is that what we want to do? So for the left one, no, we need the width to be, let's put that here. Width minus 1 minus I. So if we start at 0, we want this to be 4 positions over. Is this correct? So the first time through, and again, if we had 1 0 1 1 1, our first bit through would be 1, and then I would want to shift it over by 4, which would add 4 zeros. 1 2 3 4. Yeah. Then the next time through we would get a 0, and the 0 would be shifted over 3 positions, and we'd add those together. The next time through we'd get 1, that would go here. Okay, yeah, that seems correct. And then we return the number. Can't find position in scopes. This would be This is at common bit at I. Let's see. Which one is an integer? Bit returns a uint, right? Yes. And we shift that over. Num needs to be a uint. Okay, and then I also needs to be a uint. Okay. Okay, so at this point we should be able to get a gamma rate. We can print gamma rate, diagnostics.gamma rate. Okay. What happened? Print gamma rate. Build complete. Swift run. That's weird. What am I missing here? Swift build 00 build complete. That seems a little strange. Okay. Build complete. Shell returned 133. So I'm guessing 133 is some sort of assertion failure. But why didn't we see that? Or did we get a force unwrap error somewhere? We can start printing out what we are getting from our reading. Let's do that. Print string value, and we can say terminator is an empty string so that we can then print out the value here. Print value. Shell returned 133. Okay, Swift build. Swift run. So something is happening here. 1, 2, 3, 4, 5, 6. Seems like we got past that and we got all of our readings. Print have readings.count readings. Weird. Okay, so we got all of our readings correctly. Diagnostics creates diagnostics, saves the readings. I'm looking over at chat because I feel like I must be missing something obvious. It's trying to get the gamma rate. Let's see. Let's see, width is that. We'll get the bit at I is bit. Really strange. Okay, so width is, did I not output the width? Reading 0.width. I didn't. Width is width. Okay, so it went from 0 to 1 less than the width, and it got to a couple of those. Bit at I is bit. Bit at 0 is 1, bit at 1 is 0, and then all of a sudden it trapped. I'm not sure what trace trap is. It must be in the common bit function. But I feel like if it was a trap, wouldn't we get one of these assertion failures? Like if I say assert false here, we get assertion failed, which would tell me something. Okay, print bits. This is something that maybe Xcode would be a little bit better at handling because I could set breakpoints and see what's going on. Sum is sum, but good old caveman debugging doesn't really hurt anybody. Okay, so we got, there's a width of 5. These are all the bits that we have to deal with. The sum of those bits is 7. And so it does 7 as a floating point number divided by 12 and cast to an integer, so it gives us 1. Then the second one has 5, so the bit at 1 is 0. And I never get anything after that. Could be force unwrap here. But how would that ever not give me a value? All right, chat. Give me some pointers. What do you think? I'm going to go heat up my coffee. I will be back in 30 seconds. Okay, let's see. What do I want to do to debug this? I have an assumption that it's the force unwrap, so maybe I could just say, let's see, let int or let x equals int question mark and then x bang. Does that give me? It does. You know what? It's interesting. I'm not seeing the output from this because I think it went to... It's either being buffered and going out on standard error, which is why the Vim pane isn't getting it. Because if I run it here... wait, what? How is it running? Save. That's very strange. I wonder if the compiler just compiled this out entirely. Doesn't seem like it would. So this one gives me a fatal error, not a trace trap. So I'm not quite sure what would cause that to happen. I'm going to open this up in Xcode because I'm thinking that Xcode will give me some, more info about this issue. What if an assertion fires? I do see the assertion in the output, which is why I'm a little bit confused by that. Okay, let's run it in Xcode. Okay. Arithmetic overflow. Okay. So I said that num was an unsigned integer. But it's... why is that a problem? Arithmetic overflow. So num is 16 at the moment. And it doesn't want me to... Do I need this width -1? I don't think so, because I think the bit shift operator has less precedence than the subtraction. This cannot be... okay. Is that why? It is why. Okay. So just to back up a second, that was a little bit frustrating that we don't get any kind of output. We just get a trace trap and no output from running this in terminal. But okay, so this is what we had before. So what it was trying to do is bit shift this left by width -1 instead of width -1 minus I. And then it was adding that together. So width -1 was always 4. So if the bit was 1 and we're shifting left by 4, we get 16. And then adding that to, and then subtracting I, which would be an increasing number. But then the next one would be 16. Yeah, it's just strange. I'm surprised that overflowed. I would understand if we got the wrong answer. But why would it overflow? Because we're only going through this 12 times. It's just like a tiny number. And it would even be less than that if I'm doing my math right. Because our width was 5. taking a number and bit shifting left by 1. The only thing I can think of is if I did a -1. Yeah. uint -1. Ah, that's why it worked for a couple of them when I got to the end. It was it was a 0. That's what it was. Remember that bit was 0. And then we subtract 1 from that, so we get -1 and it fires. Okay, arithmetic overflow. Yeah, that's unexpected. I suppose you can tell I don't work with bits at a low level very often, because I probably should have seen that, but okay. I'm going to save those. Let's quit Xcode. Let's go back to Vim. So we have our gamma rate, we have our readings being output. We don't need the bits or the sum anymore. Let's build, run. Okay, and now we have a gamma rate of 22. So our 22. Okay, so then the next one was epsilon rate would be 9. So that's going to be very similar. Gamma rate var epsilon. I believe we can copy and paste because we're doing least common bit. And now it kind of seems like I want to have a function that can do this a little bit better. So we could say func, I don't know, construct int from bits, where we have an array of bits and I want to get an actual int out of that. That's why I tend to not use uints in a production code. Every arithmetic operation with a uint is a potential crash. It's true. Honestly, the reason why I reached for uint in this case is because negatives, I don't want that left bit to mess with the number, the leftmost bit. Because if that leftmost bit is a 1, then the number is negative, right? And so it seems like if I'm just dealing with positive integers in my interpretation of the bits, it seemed like the right thing to do. But yeah, I also didn't know it would crash, honestly. I assumed that, like in C, it would just wrap around, but Swift being safer in that way, I suppose that is just one of the features. Okay, so what I'm thinking is that if you give it a bunch of bits, that I could go through all of these bits, and let's see, I kind of want this reading width to be a property, because notice that we're asking for common bit many times, and we're asking for this max width here many times. So what if we say reading width is an int, and we just get the maximum width out of this? Or 0. And now we can say, come on, reading width. So that will be computed one time. And then that's this. Okay. And I can't use lazy if this is a struct. And I don't necessarily think this needs to be a struct, so I'm going to change it to a class. So now the gamma rate, we don't need that anymore because we can use reading width here. Come on, reading width. Okay, and there was one more. Epsilon rate. Yeah, so the epsilon rate, I actually don't want to do it like this. What I would like to be able to do is say, given the range of 0 to the reading width, I want to map that to, so that gives us my I in, and I want to get the least common bit at I, and that's going to give me my bits. And then I want to return construct int with those bits. So that's the thing I want so that I can reuse this code. So now constructing an int, let's see, we just need to get the bit. We have the width already. So this would be bits.enumerated dot for each gives me the index and the bit. And actually, I am now reducing this number. So this is actually not a for each. This would be reduce starting at 0. And this gives me the sum, the accumulated value, and, well, the num, and then the this actually is probably, this might be a little confusing. So we've got the num, which is going to be a uint, and then we've got a tuple, which is the index, which will be an int, I think, and then the bit, which will be a uint. And that needs to return a uint. Okay. Let's see. So this will be the item, which is that type. Okay. So now I'm not plus equals the number. I'll say num plus the item.bit less than bits.count minus 1 minus item.index. Okay, so if I've done that correctly, let's do the guard here. And actually the guard can go here because if the bits are empty, we return 0. So we don't need that guard anymore. So now least common bit, and then this one becomes this guy. That is the common bit at that index. And here we return that number. Let's run it and see if we still get 22 for our gamma rate. We do. And now let's get our epsilon rate. Okay, and we get 9, which is correct. Okay, so our day 3 answer is the diagnostics.gamma rate times, actually this was the power consumption, so we can actually make that a computed property. Power consumption uint is gamma rate times epsilon rate. Let's see. Power consumption. Okay, 198. And let's take a look and see, is that the correct answer? It is. So let's get our puzzle input. Copy. We will go back over here to day 3.input. Then we will go over here and change test to input, build and run. Okay, and our power consumption is a huge number. Submit. That's right. You're 1 gold star closer to finding the Slay keys. Okay. If you have only 1 number left, stop. This is the rating value for which you are searching. Otherwise, repeat the process, considering the next bit to the right. So our numbers here. So we're going to go over here and we're going to say, I think oxygen was start for the oxygen generator rating. Start with all 12 numbers. Consider only the first bit of it each. There are more 1 bits than 0 bits, so keep only the 7 numbers with a 1 in the first position. Yeah, so we're just going to be recursively filtering it, starting with the most common bit from this position, then filter the next set of numbers to that one, and I believe the other one's going to be the opposite. The oxygen or CO2 scrubber rating is the least common bit. Okay, let's do it. So over here, we have gamma rate, epsilon rate, we've got O2 rating, and we've got the CO2 scrubber rating. Is that what it was called? CO2 scrubber and oxygen generator. Generator. Okay, let's have both of these return 0 so I don't get any syntax errors. Okay, so we can start by, say we have our readings, which is self.readings. And then we're going to be looking at each bit. So we can say for I in 0 to the reading width. So for each bit, we can get the common bit, which is common bit at I. And then we want to set readings equals readings.filter. And this gives me my reading. And I want to filter out ones where the reading bit at that position equals our common bit. And turn 0 still. Okay. If readings.count is equal to 1, then I just want to return it. Well, I want to return this reading. This first reading. Readings 0. Otherwise, we continue to do this. And if there's not a single result, I'm not quite sure what to do. Maybe I'm just going to return 0 so that we will see it. Okay, so we need the O2 generator rating. I'm going to swap back to the test input here. And we will say O2 generator rating. Okay, and we got 0. We may need to add some output to this. Let's see. 0 to less than reading width. We get the common bit at that position. Then we filter out the readings to include only ones who have that bit at that position. And then if we have only one left, we get this. Okay. How did this even compile? That isn't working. It shouldn't compile because I'm returning Oh, I'm always returning readings. This needs to return readings 0.value. And value is inaccessible due to private protection. Do we want to allow reading to be readable? I suppose that is fine. Okay, O2 generator rating is 22. Is that correct? No, it's not correct. 10111. Okay, let's print out the readings as we're going, so we can see what's going on. So we'll print bit position is I, and then we'll print readings, and then I will add in readings joined with a separator of new line in a tab character. Joined components joined by. What is it called? Joined by separator. I thought there was a joint. Joined separator. Joined separator. What is the separator? What was it called? Reading has a... we never saved the string value. We probably should. Okay. Okay, so now we should see bit position 0. Here are our readings. Bit position 1, 2, 3, and 4. We get 1, 0, 1, 1, 1. That should equal 23. Are the readings numbers? Yeah, the readings are a representation of this 5-bit binary representation, and its input is a string. And then we need to be able to get the bits at given positions starting at the left. But then when we turn it into an integer, it's, Indianness is, this is the least significant on the right side. And so I think that, am I doing this backwards? No, this should be an odd number. And no matter which way we were to process this, this should have an odd result. So what am I doing wrong here? We have one reading left. We get the value at that reading. I meant in your array, but you already did the thing to get the string value for each one. Oh, yeah. So we take that string value directly and turn it into a value here. That is curious. So just as a little bit of debug code, if I take the value int from the string 10111 radix 2, this should give me a 23, and it does. O2 generator rating. I suppose I do need to be careful that readings, because it's shadowing the property. Perhaps I could change this. For filtered readings. Filtered readings, and also here, just to make it obvious that we're not using the full collection. All right, let me run this one more time. How is that possible? We started out with these. The common bit is 1, so it should filter out all the ones the rest should have a 1 in this position. Now we're looking at this position. The common bit is 1, 2, 3, 1, 2, 3, 4. So the common bit here is 0. So the second ones should all have 0, and they do. Common bit in the third position is 1. They all do. Common bit in this position here is 1. And I'm not printing it. Oh, okay. I know what's happening here. I suppose it would be a little bit nicer to put that there so we can actually see it. But what's happening is we're getting this one instead of this one. So you see in this position, they had a tie. There was a single 1 and a single 0. So who wins? Well, in that case, I think it does tell me. In the fifth position, there are equal number of 0 bits and 1 bits. So to find the oxygen generator rating, keep the number with the 1 in that position. So the way that we're finding the common bit here is we're rounding. And for some reason it chose 0 there. So we got 1 out of the total, which was 2. Seems like this should have actually worked. 0.5 should have rounded up. Let's do... Why is the sum 5? Ah. Yeah. Okay. So now the problem is this common bit is getting the bit of all of the readings, not my filtered readings. So I think this common bit thing should take an array of readings. And same thing for least common bit. And that's going to make a handful of these fail in readings. Okay. So now when I get this, I can get the filtered readings. So we get the common bit at the filtered readings, so then we refilter. Yeah, that should work. So now we get 23, which is correct. Okay. So let me get rid of a few of these diagnostic messages. That guy. Okay. And then the CO2 rating is essentially the same thing, but this time we're doing least filtered. And similar to how we did, like, we wanted the gamma rate and the epsilon rate to sort of share as much code as possible. So we moved most of it into construct int. I'd like to do the same here. This would be something like, we would need to know, let's see. It's kind of like everything about this is common or shared logic except for this single line. And so I would need something to say, like, please give me a function that can be used as like a strategy. Either that or give me the filtering each time. I don't have a good, like, abstraction for this. The naming seems awkward, which means the abstraction seems a little awkward. Let's see. So if I took this whole code here and said private func filter readings using filter block, and the filter block takes a position and returns a new array of reading. And then this returns the single reading that is left. So we start off with filtered readings, then we do this, delete all of this stuff, and say filtered readings equals filter block I. And then here we can do that. And then at this point, I think I need to have this return an optional, like if we get through all of them and there's no way to get a single one, then we have to return nil. Okay, so filter readings. If we do that correctly, we should be able to say return, or we don't even need a return statement. We can do it in one line, I think. Filter readings. And this one would say get the common bit. This needs to return the readings as well, or provide the readings into the block. So I can say return readings.filter. Alternatively, I just need this. But I still need readings here. Yeah, readings.filter, and then do this one. And then this one would return the value or 0. Okay, let's get rid of that. Save it. And this guy needs to provide the array of reading here. And yeah. All right, build. So we still get the same answer, which is good. So now we can do the CO2 scrubber rating. Change that song. Okay, so this one now gives us the least common bit. There's still a little bit of similarity here, but it's kind of like I want to figure out which bits do I want to keep. But again, I don't really know what abstraction would even make sense. If there were more requirements for this, then we may arrive at a better design. But I think this is close enough at reusing some of the code. And this also lets me reuse the sort of debug output. Okay, so our CO2 scrubber rating is now 10, which is correct. To find the life support rating, multiply oxygen generator by the CO2. Okay. I'm going to comment these out just to get less output. And we will say life support rating is O2 generator rating times CO2 scrubber rating. Okay, and we run this, and we get 230, which is great. I still have a print statement, which is this guy, printing a bunch of blank lines. In fact, I don't really need that. I can put it here. Plus new line. Okay. Let's switch it over to our live input. Build and run, and our answer is that. Okay. Day 3 is complete.